So we've looked at what potential dividers are and the two formula that link to them, and now we're going to look at actually making calculations with those formulas. So first task is going to be to complete this table. Formula is V in equals V1 plus V out. So V in 9 volts, V1 is 3 volts, so V out is literally 9 minus 3. Go. So the first set of calculations you need to do for potential dividers is the basics of the voltage in equals voltage 1 plus voltage out. And you've been given a table and it is as simple as this. The voltage in is 9 volts. If voltage 1 is 4, then the voltage out must be 5 volts because 9 minus 4 is 5. If we have the two voltages across the resistors as 3 and 4 volts, then the total voltage in must be 7 volts. And finally, if the voltage in is 6 volts and the voltage out is 2 volts, then voltage 1 must be 4 volts. Okay, so the next formula, which is to do with the ratios, is a little bit more complicated. So what I've done in the table is I've broken it down for you. So you've got your V in, R1 and R2, which are the values that you're using, and I've broken your formula down. So the first stage in your formula is to calculate R1 plus R2. That goes in this column. The next stage in your formula is to work out R2 divided by R1 by R2. So you then have your value of R2 divided by the answer from this column, and then the final thing is that you multiply it by V in. So I've just realised I've written it out there. So R1 plus R2, so we've got 100 plus 100, so we've got 200R, and then we've got R2 divided by R1 plus R2, so R2 is 100. That's divided by the 200 we've just got from this column, and that obviously is a half. And then the final thing we do is we use the answer to this column and we multiply it by the voltage in. So it's a half times 3, so that is 1.5 volts. Okay, that one's quite an easy one. They're going to get a little bit more difficult as you go through, and one of the things that you need to do is when you're doing these calculations, if you come up with a decimal number, round it to 2 decimal places. So our next one, we've got 6 volts, 1K and 470R. So the first task is to add R1 and R2 together. So not forgetting that 1K is 1000, so that's 1000 plus 470, so that's 1470R. Okay, that's the first bit. So the second one is R2 divided by that answer. Well, R2 is 470. That goes over 1470. That comes out as a horrible number. So we're taking it to 3 decimal places, and the 2 decimal places, and that's 0.32. Last column, we're multiplying by voltage in, which is 6 volts, so it's 0.32 times 6, which gives us 1.92 volts. Okay, last one. 9 volts in, R1 is 4K7. Now what that actually means is 4.7K, which is 4,700. So we're adding 4,700 to 10,000, which gives us 14,700. So R2 is 10,000, so the formula here is 10,000 divided by 14,700, because we're taking this number and dividing it by this one. That once again gives us a decimal. Rounding it to 2 decimal places, that gives us a 0.68 as a number. And the last thing we're doing is we're multiplying the voltage in by 0.68. So that is 0.68 times 9, and that gives us an answer of 6.12 volts.